In this series of videos I'm attempting to repair and restore this vintage Osborne OCC1 computer. In the videos so far in this series I've carried out a few repairs, had a couple of faulty RAM chips, I've replaced those, refurbished the disk drives, not fully tested yet, and did find a fault with the drive B which I have now fixed, and I got it to the point where it would apparently boot to the startup menu from floppy disk. So initially it was booting to the welcome screen and wouldn't go any further, and that turned out to be faulty RAM and a couple of other minor faults I've been fixing, so got that working. But to boot it I was fooling it into thinking I was pressing the return key by just jumpering a couple of the pins on the keyboard connector. Did get the keyboard working intermittently. Initially I was just getting flickering on the display because it thought one of the keys was permanently depressed. In fact, it thought about 4 or 5 keys were permanently held down. So I showed a method I was using to try and correct that, of heating up the area in question beneath the faulty key, applying the vacuum to that area to kind of dome up that area of the membrane key panel. But I was chasing myself in circles with this. I'd get one key working, then another one would stop working, and it was just very flaky in the way it was behaving, and it was kind of getting worse over time, and every time I moved the keyboard some more keys would stop working, or rather would be permanently indicating that they were pressed. So this keyboard, I think the design really lets down this machine. It uses a membrane panel, and then there are a series of mechanical plungers. So there's one like this for each key. So it's the keycap, a plunger, the base, and then there's a small spring that sits on the bottom of this plunger, and that's what presses on the membrane. So it's not really a mechanical key switch, but it does give a reasonably nice feel. But in my opinion, using a membrane in this class of machine is not a good idea. It might be okay on something like a ZX80, ZX81, which is a very low cost machine. But on a machine like this, I do not think a membrane's a good choice. Having said that, I couldn't really believe that it would be, or should be, this unreliable. Unless I'm extremely unlucky and I've got the most unreliable Osborne OCC1 on the planet, I couldn't believe that they would be this bad. So in the previous video I got as far as I could until I get the keyboard issue sorted out, and rather than just throw the keyboard in the bin and wait until I could find a new one, I wanted to start looking into various options. And there are many different ways I could go about trying to resolve this. I could make up a new keyboard PCB. I could try and modify this one to accept different sorts of keys. There are many different options for this. I could find a pre-existing keyboard and then, if necessary, change the lookup table in the monitor ROM to take into account the different scan for the different keys. Swap the keycaps onto the new keyboard. There's a lot of different things that could be done. But one thing I wanted to try and find out was why this particular keyboard is so unreliable. So that's what I'm going to look at in this video, is try and get to the bottom of what's going on with this keyboard. So I'll just move the camera. So as you can no doubt tell, I've started dismantling this keyboard. So the way I've taken this apart is pull off the keycap. You can then pop out the plunger. These are just held in place as a spring sits underneath, and you can just pull these up and they will pop out of the housing. And then I've been removing the housing, and that's the only real, it's not tricky, but it's just time consuming. It's taken me about an hour to get this far, so it's not taken all that long, but the problem will be, of course, reassembling this. So I wanted to get these out in such a way that if ever I need to, I can reassemble it. And the way they're held in is they're pushed through some holes in the aluminium backing plate, and then as you can see the plastic tab is heated and mushroomed over, so effectively they're plastic welded into the metal plate, which means it's quite difficult taking this thing apart and dealing with the key issues. I also removed the interface PCB, so this is what these two flat flex cables plug into, and then the curly lead that goes to the computer plugs into this connector, and that's just held onto the backing plate with double-sided tape. All you need to do then is get the key plunger housing out, and the way I've gone about that is I've got a soldering iron. I've set it to quite a low temperature, about 280 centigrade, and all you need to do then is just put it onto the bottom of where these are welded over. It helps if you just run a heat gun over it first to get it fairly warm, and all you need to do then is put the soldering iron on, slide it across, and you can then just push away the welded part of the key plunger housing, and you just do that for each one. Doesn't take very long, it's just really a case of pushing these off. And you can see it just takes a few seconds to do each one. And what you can then do is just use a small screwdriver, push these through. You don't want to push it too far because otherwise you'll snap the other one off. The two in each one at the diagonally opposite on the plastic moulding, and if you push one down too far you'll snap off the one that's on the opposite end. So you just push it down a couple of millimeters, move on to the next one, and then they will drop out of the bottom. So I'll just get the rest of these off, but before I do that we'll just flip it over. And I got as far as removing the first few key plunger housings, and then tried lifting this up to see what was underneath. I wasn't quite sure if this was bonded to the aluminium or not, and as soon as I lifted this up it became very apparent what the problem was. So no doubt you can see it as well. It's all this corrosion, and this has kind of bubbled up and it's pushing up on the underside of the membrane. Also, there's unfortunately this is not a good idea to use this anyway, but the way it's been implemented is all these holes for the plunger housings. So there's hundreds of small holes, and you can probably see corrosion all over this, and that's allowed corrosion to get inside the membrane panel. So I'll finish taking this off, we'll flip it over, have a look, and you'll see hopefully what the issue is, and we'll try and figure out if there's anything we can do to recover this. So that's all the plunger housings removed, and we should now be able to lift the membrane off the backing panel. Not quite sure why that part was stuck. So we'll look at the plate first, and you can see there's a lot of corrosion underneath this. And like I said, it's very uneven, and there's kind of lumps on here that are pushing up on the underside of the membrane panel. There was a lot of signs of water or fluid ingress into the case, or the keyboard case that this normally sits in, so I think there's been liquid spilt into this. But there was evidence of corrosion all over the machine, so I think it's just been stored somewhere very damp, and obviously this is a side effect of that. But looking here, you can see there are clear signs that water or fluid of some sort has been flowing across this, so that could well explain why this particular keyboard is so unreliable. Okay, so you can possibly see this. I don't know how well it will come across on the camera, but there's a lot of corrosion inside this, and the way these are made up is a multi-layer sandwich in effect. We've got this top layer, and this has a conductive grid on the underside of it, and then we have a separator layer which keeps that top layer away from the third bottom layer, and the bottom layer has another conductive pattern on it, and these form the keypads. And then when the top grid layer and this bottom layer come together, when they're pressed, that forms the conductive loop, and effectively that forms a key. But what's happening here is this is not opening again. It's quite a thin separator layer, and what's happened here is partly because of the corrosion on the underside, which is on here as well. I can kind of feel big lumps of it obviously pushing on the underside of this and causing it to hold the key shut. But also there is corrosion inside. I'm going to clean this bottom layer off and see if anything can be done about it. I could of course put this in an ultrasonic bath. Now I repaired or showed some repairs of a mechanical key not too long ago, and I showed how to get the key apart. I then put that in an ultrasonic bath to clean it, but when it was dismantled. Now someone suggested in the comments on that video that you could just take the key intact and put it in an ultrasonic bath. That tends not to work that well, because while the ultrasonic bath might loosen all the dirt's still going to be inside the key housing, so you really need to find some way of getting it out. And the same is true here. Although I can put this in an ultrasonic bath, it might loosen up the dirt, but it's still going to be trapped inside this thin sandwich, which obviously we don't want. What I'm going to do is clean this off so that all the lumps and bumps have gone, and then with it lying flat I'm going to buzz it out and see if that has actually resolved the problem. If it has, I can clean up the aluminium plate and then reassemble everything. If it hasn't, then that's where the fun and games will start. I'll have to try and find some way, if I want to restore this, of getting the keys to function again. It's possible, depending on the nature of the glue or the adhesive that was used on this, that if I try heating it up, I might be able to get the bottom layer to peel off the other two layers. And if I can do that, then of course I can give it a proper clean and get it working 100%. But normally that doesn't work too well on this type of membrane panel. The adhesive is normally fairly permanent, and it's extremely difficult to get the layers apart without damaging them. And usually what will happen if you try and separate them is the conductive, or part of the conductive path, will stay on one side, part on the other side, and you end up sort of tearing it all apart, and then it doesn't work at all. We don't have a great deal to lose with this. It doesn't work well enough anyway to be considered repairable, unless cleaning it will bring it back to a fairly reasonable state of operation. But I'll give this a clean first and I'll try that. Failing that, then as I say, it might be possible to come up with some assembly where I can reuse these plungers, maybe have a PCB with smaller switches that this plunger operates, and go that way. It kind of depends on what I find with this, and there are quite a few options, but we'll have a look at this first and see if anything can be done with it. I've been playing with this panel now for about an hour, and it's behaving in a real flaky manner. Sometimes it will work. It's not showing as bad as it was when it was assembled in the keyboard. I'll buzz it out and maybe it'll buzz out okay. I'll plug it into the machine, it'll work for a few minutes, but then if I sit and do nothing, just leave it lying here, suddenly it will start, the display will start flickering as if there are keys being pressed. Despite my cleaning it very carefully, it was a lot better. I only had one or two keys then that wouldn't work properly, but one or two keys is enough on this machine to stop it running at all. So I decided to get a bit medieval on it, and what I've done now, as you can probably see, is separate the top membrane layer from the center membrane layer, and that separates the two key switch layers. So you get one set of contacts on the bottom layer and another set on here, and they're connected through the two flat flex cables through to the control cable. And you can probably tell, in fact the display does seem to be flickering still, but that's just the camera shutter. But if we now try to trigger the what I'll do now is raise the camera slightly so you can see what I'm doing. So what I'm going to do now is try shorting the 2 pins that equate to the return key. And as you can see, that's had the desired effect. So in other words, I'll just reset this so it doesn't keep making a noise. So as you can see, it's definitely an issue with the membrane on this keyboard. And when I took it apart, a few of the pads were definitely, they kind of domed up a little bit, but also there's a lot of contamination in here, some kind of liquid, not quite sure what it is, but I think it may also have been sticking the pads together. So it's probably beyond help, but we'll keep going just for a bit of fun. What I'm going to do now is clean all this very carefully with isopropyl alcohol. I'll try reuniting the 2 parts and we'll see if that's had any effect whatsoever. I somehow doubt it will have, but it's, as I say, a bit of fun, and we'll see what the outcome is. I spent some time cleaning out the contact areas on both parts of the panel, and it really was dirty. There was a lot of dirt and debris in there, and as I said, some kind of weird liquid was in there that may well have been helping to stick the 2 parts together. Now I've been looking at this. I was obviously going to reunite the 2 parts and stick them back together, but I actually don't think it would work still. I still think I'd have issues. And the reason for that is due to the size of these openings. And I'll just get a piece of paper and a pen and explain what I think the problem is here. So the way this panel is constructed, there's a bottom layer, and that has a conductive pattern on it, and that includes some areas for the keys themselves. There's then a separator layer, that's the blue layer, and then there's another layer that has another conductive pattern on it, including some adjacent conductive pads, and these form the keys. So when you press down on the center of one of these, it deforms the top plastic sheet, pushes it down, and that brings the 2 pads together, and that forms the key switch. And of course there's a whole array of these, or matrix of these, that form the keyboard. And the way this keyboard's been constructed is we have a plunger on a spring, but the plunger does not directly push on the key panel. Instead there's a small spring that sits in the bottom of this, and normally it's not pushing on the key panel, but when you push the key down it pushes out the spring, and it's the spring that actually presses the panel. It's a very light spring. So in order to keep the force of the key very low, what they've done is made these openings in the separator layer very wide, and the wider or the bigger the hole, the less force is needed for a given thickness of panel, the less force is needed to close the contact. The problem is that if the force is too low, then it can stop the key reopening, and the slightest, because this separator layer is only 0.1 millimeters thick, so then the slightest deformation in the either of the 2 layers, the bottom or the top, or even of course if they're both deformed, will stop the keys from opening. I think that's what's happening, and they were kind of aware of this being an issue, because if you press the key down for any length of time, it's going to permanently deform the top plastic sheet slightly. And they were aware of that to a certain degree, because on the caps lock key, which latches down, they have a very thin metal sheet, and that's to stop this plastic layer from permanently deforming when the caps lock key is left down. And of course that issue that we're seeing of keys being stuck shut is what is causing the problem for the machine not booting, and so we have to find some way to make sure that the keys reopen. And of course, if I just stuck this back together and either of the layers was deformed, then it would just short out as soon as I stuck the whole thing back together. So what I've decided to do is modify this slightly and make these holes slightly smaller. So if I reduce the diameter of these openings, it will increase the amount of force needed to close the key, and also it will have a tendency to open the keys more reliably. Now if I go too far, of course, it means that the spring that's in the plunger won't be strong enough to actually close the key. Now I can stretch the spring, of course, it's very light and increasing that a bit isn't going to matter, but I don't want to go too far because otherwise I just won't be able to get the key to operate properly. So it's a combination of how thick the I'll obviously have to use some sort of plastic. If I use paper, then it's going to get damp and start conducting and make things even worse. So it will be dependent on how thick that plastic sheet is and how big I make the hole in the center of it. So what I've come up with is this. So this is cut out of vinyl. Use a laser cutter to make this self-adhesive vinyl. It's 0.1mm thick, which is slightly thinner than the blue layer, but it should hopefully be the right kind of size to make sure the key reopens and doesn't stick shut, and not have such a small hole in the center that the force required is excessive. So I've gone for a 9.5mm opening. It was 12.5, and then the outside diameter, of course, is just very slightly smaller than the opening in the blue layer. So I'll make 69 of these, stick them down into the appropriate places, and then I need to reunite both parts of the key panel, and hopefully it will then work. But I've only got one chance at this. Once I stick it back together, it's extremely unlikely I'll be able to separate it again without doing some damage. I was lucky the first time, assuming it's not damaged. I still don't know if that's the case, but almost certainly if I try doing it a second time, something would fail on the one layer or the other, or both. So I'll get this done, and then we'll look at how to get this reassembled, and we then need to figure out a way of lining this up properly when we bring them both parts together. That's all the spacer discs fitted, and as I said, I've reduced the hole on most of the pads to 9.5mm. The only exception is the caps lock, which has a larger opening, so that's up to 11, and it was 14.5. So I've reduced them all. Hopefully I haven't gone too far. I would have liked to have started with a slightly larger hole, maybe 10.5 or 11mm. But as I said, I only get one chance at this, and it's probably better if I err on the excessive force required side rather than them not opening, which is obviously the main purpose in doing this. I can always stretch the springs a little bit if I need to increase the force, but I can't really do much if they won't open. So with that said, the next thing I have to do is figure out how to get the two parts of this membrane back together accurately. If they're not properly lined up, then it's obviously not going to work, and also if I get a wrinkle in one part or the other, it's not going to work. So I'm going to make a simple jig, and that will make sure I get the parts properly aligned, and once I've done that, we'll get this reassembled, and we'll test it and see if we're making any progress. This is my alignment jig, and I put this together just to make sure I get the two parts of the panel properly aligned before I bring them together, because once they touch it will be almost impossible to get them back apart. So it's just the aluminium backing plate off the keyboard, a couple of bits of MDF underneath, put it into the mill, drilled through, and I did that just to make sure that these are perfectly perpendicular to the the plate. And then it's just some 2mm steel pins. I've ground a short taper onto the end to make sure it goes through the holes easily and it doesn't hang up. And as long as I pick the right holes on each of the two parts of the panel, it should bring them together very accurately, and then I can press them together, slide the whole thing off the pins, and just run a roller over it to make sure they're properly stuck together, and we can test it and see if it actually works. It won't be properly held together until, or if and when, we refit the plunger housings, but we will at least be able to get some sort of idea as to whether or not the keys will actually still function. That's the first layer of the panel slipped over the pins, and what I'll do now is bring the second part, align the pins, very carefully lower it, and then bring the two and press them together, and hopefully the adhesive will still stick them together. Unfortunately, I can't do this on camera because I can't reach around the camera enough to be able to see the pins, so unfortunately I won't want to show you that, but all I'm going to do now is get the second layer upside down, of course, line the pins, and then just very carefully lower it. I've slid the second layer down the pins, and it's now properly aligned with the first layer, and what I can do now is just press this together, and then I can lift the whole assembly off the pins, and we should have a properly aligned panel. I've reconnected the keyboard to the machine. I haven't taken it off the jig, I don't really need to, I can leave it where it is. I did clean the aluminium plate before I did this, of course. And all being well, what should happen now is I should be able to turn the machine on, and it shouldn't keep cycling around as if though a key is pressed, which is what it was doing all the time before. And we should also be able to try and find the return key and see if it will boot. Assuming this key panel still works, of course. So I'll get the machine powered up. Okay, well, no magic smoke is escaping so far. Let's wait for the display to come on. And we do have a display, it's not flickering, and somewhere around here there should be the, there it is. So as you can see, it's working. It won't boot up, there's no boot disk, but the whole point is that it responded to the key press, and also there is no key continually held down. If there was, then the display would now be flickering, and it is responding. So it's quite a light touch it needs on the keys. It's not excessive, so it does feel like that might be quite a reasonable amount of force. Let's try it one more time. So it's actually quite a nice light touch, but it does need a positive touch. It's not just going near it, which is what it was before. Also, it's reliable. What I'm going to do now is just leave it here powered up for a few hours. I was doing this before and it would work now and again, but then it would start misbehaving. So I'm going to leave it running like this, let it all warm up, and assuming that it doesn't start misbehaving, I can start refitting the key plunger housings. I also need to make sure that the springs that are used are still strong enough to operate the keys. So we'll come back to that in the next video. Assuming this carries on working, we can start trying to reassemble the keyboard and hopefully end up with something that actually works. It's looking fairly promising. I don't know if all the keys work. I don't know if I damaged any of the tracks or traces on the key panel layers when I was working on it or trying to separate it. I had a look under the microscope. I can't see any damage, but you can't see all the traces because some are covered up with the various layers. But it looks alright. I didn't get any sort of nasty kinks or folds while I was taking it apart, so fingers crossed that will be okay. But it is looking like we might have made some progress, and even if it doesn't work, it's still a fairly interesting experiment to see what we can do with what was otherwise a scrap keyboard.